Hello and welcome to that course entitled Machine Dynamics. So maybe the first question you have is, what is this course all about? A course entitled Machine Dynamics given by a lecturer, me, Professor Carsten Proppe. I'm professor in engineering mechanics, so a lecturer who is professor in engineering mechanics. So basically, if you look at that courses and machine dynamics that are taught in Germany, then you would find two different kind of courses, I would say. The first one are courses that cover vibration theory. So usually the theory of some rigid body systems that vibrate, some multi-body systems that vibrate, sometimes even continuum systems. And then there are some other kind of courses in machine dynamics that take the word machine dynamics word by word. So they start with the machine, that is with the application, and dynamics comes second. So that means we are starting with an application. The application is always in the foreground. And however, there is still a theory, dynamics, but that theory develops in the background. So this is very different from what you had as courses in engineering mechanics, where you learn the theory or a certain method, and then you apply that method to specific examples or applications. Here we teach these things in a different way. We start with an application and we apply methods from dynamics to that application. So first of all, we have a problem, a technical problem. We apply our methods, and finally we get some conclusions, some practical conclusions. So we learn something new of these machines, how they behave, how their dynamical behavior can be characterized, and what kind of effects can take place in these machines. But that's all about machine dynamics. And now there are two courses on machine dynamics. One course is entitled Machine Dynamics, and there's a follower course that is entitled Machine Dynamics 2. Yeah. What is the difference? Well, you can see it here. The difference is in machine dynamics, the theory that develops in the background is a theory of ordinary differential equations, while in Machine Dynamics 2 we deal with partial differential equations. So in order to give you some examples, I will state the syllabus of that course in machine dynamics. So the first subject will be vibration isolation. Vibration isolation is basically the opportunity to repeat what you learned in engineering mechanics about single degree of freedom oscillators. Starting from that point, we will extend that theory of single degree of freedom oscillators by looking at the bending vibrations of rotors, namely of the Jeffcott or de Laval rotor. So we consider bending vibrations, and we extend the theory of linear vibrations to some special cases where interesting resonance phenomena already appear, even for these linear ordinary differential equations. After that, I will treat the theory of balancing of rotors, and even there will be some new effects like parametric resonance that we will discover. Then we move to drivetrains, and we will study the torsional vibrations of these drivetrains. And finally, I will cover the subject of reciprocating engines, and we will discover a mechanism, so something that has a periodic but not a harmonic motion, and we will study that these reciprocating engines then. Yes, these are the subject of that course on machine dynamics. Now the question is, what is the difference between machine dynamics and machine dynamics 2 regarding the organization of the courses? Regarding the subjects, you can see the subject of that course of machine dynamics. Regarding machine dynamics 2, as I said, we will cover partial differential equations, mainly journal bearings, rotors and journal bearings, belt drivers, for example, and the bending of turbine blades. So what is the organizational difference? Well, for that course of machine dynamics, there are exercises. These exercises are structured a little bit the same way, I would say, as in engineering mechanics. So you have a problem sheet. At the beginning of that problem sheet, you find a summary of the necessary theory and the necessary equations, and then you will find some problems. That's very important, because at the very end of that course, there is an exam, as always, and that exam is a written exam. So by going through these exercises, you should be very well prepared to take that that written exam, because the questions and the problems in that written exam resembles, I would say, they resemble a little bit the problems that you have dealt with in the exercises. Regarding machine dynamics 2, there is no written exam, but an oral exam. So as you can see, the exam for these two courses are two separate exams. One is a written exam for machine dynamics, and for machine dynamics 2, there's an oral exam that lasts for 20 to 25 minutes, and you get an appointment for that exam by sending me an email to proppe@kit.edu. Well, as there are different exams, the question is, can I take these courses either in a different way, starting with machine dynamics 2 and then the course of machine dynamics, or just taking one of these courses? And the answer is yes, this is possible, as these courses treat different subjects. They are, I would say, more or less independent. There is just one, but very small dependence in the course of machine dynamics 2 on the Jeffcott rotor, which I deal with in the subject of bending vibrations of rotors in machine dynamics, will be treated again in machine dynamics 2, and I will study the Jeffcott rotor in journal bearings. But the equations of motion of that Jeffcott rotors are quite simple. So I assume that you will be able to follow that course of machine dynamics 2 without having the course machine dynamics before. So therefore, I also invented these two different names for these subjects. However, there's one thing that is very important, that you followed your lectures in engineering mechanics, especially engineering mechanics 3 and 4, of course. And not only that you followed these lectures, but we'll assume that you have knowledge of the contents of these lectures. Of course, there is a little bit of repetition at the very beginning of the lecture of machine dynamics regarding that subject of vibration isolation. We will rediscover again the single degree of freedom oscillator, but I will be very quick on these subjects because I assume they are known to you from your lecture in engineering mechanics. So what is required in order to follow that course is a good knowledge of engineering mechanics. If I talk in that lecture about a machine, what I assume as a machine is just a part, I would say, of that machine, namely the mechanical subsystem. The mechanical subsystem is sketched here. So basically it's a system, so it's that system with some input and some output, and the input are the forces or torques that act on that mechanical subsystem, and the output is the motion. And usually the task is to compute that motion, giving some forces and torques. And this is the way I will follow here in that lecture. So always, if I consider a machine or a problem related to a machine, it's the mechanical subsystem. So it's a part of that machine. It's not the machine as a whole. The machine as a whole is treated in some other lectures, in mechanical design, for example, or in measurement and control theory. And in order to show you the complete picture that is not treated here in that lecture, I just will give you one more slide. So in order to recover or rediscover that mechanical subsystem, you will find it here. And you can see that the whole picture, the broad picture, is much larger than just the subsystems. Mainly there are perturbations. We will study the influence of perturbations on that system. But as there are perturbations, we have usually a measurement and control system installed in a machine. So a machine is not only a mechanical system, but I would say in any case, it's a mechatronic system. So it contains mechanical part, but also electrical parts, of course. So there are measurements. Measurements need some kind of sensors, with which you measure the motion, for example, or some kind of forces. And from these measured signals, you have a microprocessor that processes the results using perhaps some reference variables in order to get an idea of how to control the system. So there is first of all a feedback signal, but also a control signal sent to some kind of actuators. These actuators need an auxiliary energy, and the actuators then will set some control variables, for example, by applying forces and moments, additional forces and moments to that mechanical subsystem. You see, this is the broad picture. You see that that broad picture is much more complex. It is, of course, necessary in order to get a full understanding of the machine as a mechatronic system to study that broad picture of a machine. But here, the focus is on the mechanical subsystem and to get a better understanding of that mechanical subsystem. This would be the general objective of that course, to get a better insight of that mechanical subsystem by studying its dynamics via a modeling with ordinary differential equations, and then solving or studying the solution of these ordinary differential equations. And from this solution, we will learn something about the characteristics of that mechanical subsystem. We will learn whether it's possible to have a stable stationary operation point of that machine, so regarding perturbations, whether there are some other effects like transient solutions, whether resonance is possible and should be avoided, and so on and so on. So, well, this is the complete picture, and with this short introduction into the subject of that course, machine dynamics, is finished. And in the next video, I will start with the first real subject of that course, namely with vibration isolation, and I will study with you active and passive vibration isolation in the next 3 videos. So thank you for watching this video and stay tuned until the next video. Thank you very much for your attention. See you.